All right, guys, good afternoon, fifth and seventh period. I have a baby appointment today, so I'm very sorry that I can't be there with you. However, we're going to just run through our notes for today. So we're talking about linear regression. So linear regression, okay, there's a hole punch here, but that should be LINER. Okay, it's the process of matching data to a line of best fit. Okay, and remember, any line, the equation is y equals mx plus b. Now, when we do this, you're going to get something called the correlation coefficient, which we're going to use the letter R to denote. And this is going to be a measure of how accurate the line of best fit is for the data. So there are two ways that your R can be really accurate. If your R is really close to +1, that means that your data has a positive correlation and that it's like basically perfect. Now, obviously, most things are not going to have a perfect correlation, but in general, okay, if you have a correlation close to 1, your dots are going to be like this, where they have a positive slope and they're going uphill. And so that when you do your straight line, it's going to pretty much cut straight through the data and be a really good representation for each of those points. Okay, this would be a strong positive correlation. Now, if you're going to have a weak correlation, let's do one more picture. Let's say that your dots are still uphill, okay, but they're kind of more spread out. Maybe you have like a few points that are kind of off. Okay, that would be a weak positive correlation. Okay, so that when you draw in your line, you're drawing it in, let's say like right here, but you'll notice that your points are almost like too spread out to really match the line that well. I mean, especially with like this point down here, you have basically like a pretty wide spread versus on this one, your points are sticking really close to that line of best fit. Okay, now you're going to have the same thing for a negative correlation. So a negative correlation can also be strong or weak. So let's do the strong one first. This would be very close to a -1 for your R. So -1, your dots are going to be really close to the line of best fit, and they're going downhill. You're going to have a pretty minimal spread, which means in general that your points are staying really close to whatever that line of best fit is. The reason we call it a negative correlation, though, is because it's downhill or it has a negative slope. So this would be a strong negative correlation. Okay, you can also have a weak negative, which would be like one of these middle values. Notice I can have a weak positive, like I have right here, or a weak negative would be kind of like this. Okay, where maybe your dots are going downhill, but they're not doing it in a very like tight-knit, close pattern to the line of best fit. So you can see as I try to shade in all those dots, that some of them are close, but a lot of them are off. So that would be a lot more weak because you have a wider spread. Okay, anyways, let's get into how to do it. So first thing I'd like for you to do is open up Desmos. Okay, so you're going to need your computer for this. So go to desmos.com. Go into Graphing Calculator. Okay, and you should be right here. All right, we're gonna do this for example number 1. So, Mr. McCormack and Mr. Khan, if they need a minute to get this open, feel free to pause this video until everybody kind of has their computer out. Okay, so let me read you number 1. Here's what it says. We have a 4th grade student who released a helium balloon from as high as they could reach. The table below contains the data from the balloon's flight. Okay, so it says use linear regression. That's what we're about to learn how to do to get the equation for the situation. Remember, because all of our models are linear today, that's going to be y equals mx plus b. So we're following the steps right here. Okay, first thing that you're going to do, okay, take a look at my screen, is you're going to hit the plus button right here. We're following step number 1. So it says click the plus and select table. Okay, so here's my table. Then it says type the values from the table. So we're looking at example 1. So I'm going to run down this left-hand side and I'm going to put 0, 1, 2, 3, 4, 5, 6. So 0, 1, 2, 3, 4, 5, 6. Then I'm going to come over to my Y column. And I'm going to take each of these Y values from right here. Okay, that are over there on the side. Okay. So I took my Y values and I'm going to type these in over here now. So take a second and do that, please. And then my last point there is 32.97. Okay, now notice that I accidentally put a 7 here, so I'm just going to pull that back off. Okay. And again, Mr. McCormack, Mr. Khan, please feel free to pause the video as needed. Okay, but the next thing I want you to do is after you've input that table, I want you to look at your graph over here. Okay, so I'm going to zoom out a little bit, but do you see how all my dots here, okay, are forming sort of a straight line? So I can already tell that this has a positive correlation because it's uphill. Okay. So now let's keep going on to step number 3. So it says on a new line. Okay, so I'm going to come over here to line number 2. It says type Y1. Then a little squiggly. The little squiggly is on your keyboard somewhere. Maybe you can find it before me. Oh, I see it. It's above the tab button. So you're going to have to hold Shift Tab. Okay, I'm following this step right here. Okay, and then I'm going to put M, then X1, and then plus B. Okay. All right, now you're going to immediately notice that as soon as you type Y1, little squiggle, that means approximately, mx1 plus b, once you put that equation in, you're going to notice that a line immediately pops up and it goes basically perfectly through each and every single one of my points. That's great. The reason it goes through every single one of my points is because look at my R here. R is exactly 1. And remember, 1 is as perfect of a correlation as you can possibly get for positives, just like -1 is as perfect of a correlation as I can get for a negative. Okay. So let's come down here. It gives you the M and the B. Okay, so let me circle that here. The M and the B are right here. So what I'm going to do is I'm going to sub those into my equation. So I have Y equals, writing in our notes here. My M is a 4.62. X plus my B is a 5.25. And then my accuracy here, my R is equal to +1, which remember, that is a perfect correlation. Okay, then it asks you to determine what the y-intercept is. Okay, so let's just kind of review here. This number next to the x is the slope. And this number here is the y-intercept. Remember that the slope tells you how steep the line is, and the y-intercept tells you where the graph starts on the y-axis. So that's your initial value. So if I'm looking at this graph closely here, my slope 4.62 is how steep this is, or the rise over run. If I were to count that, pretend that doesn't look ugly. And then my y-intercept, the 5.25, that's telling me how high this is hitting right here. So you can see that if this is 10, halfway down, that'd be about 5. Okay, so let's go ahead and write that down. So my y-intercept is 5.25. And my slope is 4.62. Then it says, okay, let's fill in the blanks. The student's reach, or the initial value, the starting amount, was 5.25 feet high. And then it says the balloon goes upward at a rate of 4.62 feet per second. So each time they're adding 4.62, 4.62, etc. Okay, now in real life, obviously there's not going to be an exact addition of 4.62 each time, but because my R was a 1 here, that's a perfect correlation. That means this table perfectly fits that equation. Then it says, what is the balloon's height after 14 seconds? Well, then all that I have to do is come back over here to my online calculator. Okay, and I'm going to take this equation that I just got. So y equals 4.62x plus 5.25. And then once I have that equation typed in right here, I'm going to go into my table. And I'm going to just look for the number that they're wanting me to find. So if I want the balloon's height at 14 seconds, then I'm just going to change my X here to a 14. And it'll automatically give me the Y value here. It says it's going to be at 69.93 feet high. Okay. Let's go ahead and turn the page when you're ready, please. Okay, we only have 2 more examples. You can do it. Take a look at number 2, please. Okay, it says we have a raindrop falling from a storm cloud. The table below contains the approximate data from the raindrop's descent. Round all answers to the nearest 100. Okay, 100 is going to be 2 decimal places. Okay, so it says use linear regression to get the equation for this table. How accurate is the model? So let's click out of all of these charts that we've made over here, just using these X buttons. Okay, and then we're going to follow our steps again. So you're going to hit the plus sign right here, go into table. And then I'm going to type in all of the X's first and all of the Y's second. So my X's are 2, 11, 18, and 23. Okay, then I'm going to come down here to my Y's and I'm going to input these numbers in my Y column. Okay, if you need the teacher to pause this video, just raise your hand and ask. You need time to do this. Okay. So I've just finished typing in my table right here. Then I'm going to go into the next box right here. And I'm going to do y1 squiggle mx1 plus b. And as soon as I do that, all these little values here are going to pop up. Okay, so I'll give you another minute to do that. Okay, so notice your m and your b are right here. So that's how we're going to write our equation. So it'll be y equals negative 9.06 x plus my b is 3754.87. The other thing it asks me for here is my r. So I'm going to write my r right here. It says it's negative 0.9941. So I'm going to put 0.99. Now notice that because that negative 0.99 is really close to -1, that means that this is going to be a very accurate estimate. It's not quite 1 or -1 to be perfect, but negative 0.99, that's pretty close. Okay, then it says, what is the y-intercept and the slope? Okay, remember that the slope is the one that is next to the x. So that would be your negative 0.906. I said that wrong, negative 9.06. And my y-intercept is the 3754. Okay, then it says fill in the blanks. The storm cloud's altitude or initial value, that's the starting amount, okay, is 3754.87. And it says the raindrop descend at 9.06 meters per second. So this is my starting value. And then this is the amount the raindrop falls each second. Okay. Now you'll notice that my table, just real quick, starts at 3743. So you might say, well, wait, how is this the start value if my table is starting at 3743? Okay, but remember that your table really should start all the way back here at 0. So if I'm starting the table here at 2 seconds, then I would have to work backwards to get to my 0 value. But in this case, I already know what it would have been. It would have been 3754. So it's almost like you're kind of backtracking to what that 0 partner would have originally been. Okay, then it says, how much time has passed if the raindrop has an altitude of 3281? So let's come over here to our Desmos. We're going to type in our equation. So I'm going to put y equals negative 9.06x and then plus 3754.87. And then it says that I want the raindrop to have been falling for blank seconds at 3281 meters. So the first thing I want you to think about is this time they're asking me for my x, but they're telling me my y. So we haven't really done very many of these, but let me show you how to do that. If I want to know when this happens, that the raindrop would be down at 3,281 feet, I'm going to go into my little table here and I'm going to put y equals 3,281. Okay, then I'm going to come over here to my graph. So let me make this big for a second here. Okay, and I'm going to zoom out until I start seeing my dots. Now you might be wondering, why the heck do I have to zoom out so much? Okay, the reason why is because think about the numbers that were in your table. This is 3,000. 3,700, 3,600, 3,500. So the fact that I'm having to zoom out so much, that's really not that big of a deal. Okay, I can see my dots are kind of up here. See the little red dots? Okay, if I want to zoom in on those to see how good my fit is, I can. Okay, actually, maybe I can't. Let me push this over to the side so that I can see that better. Okay. All right. So then from there, you'll notice that when I typed in my y equals number here, okay, do you see this flat line that popped in? This is the y equals for the 3,000, whatever it was. Y equals 3,281. So if I want to know where this equation crosses this line, all that I have to do is basically like hover over where that spot is, and it'll show me where that intersection is. So let me show you. So I'm going to just take my cursor here, and I'm going to kind of highlight above where the intersection is. And do you see how it gives me the value right there? So it'd be 52.279. 52.279. Now notice we said we're going to round to 2 decimals. So if it's 52.279, then I'm going to round that to 52.28. Okay. So let me put my paper back up here. Okay, so I put 52.28. Remember, the exact value was 52.279. But because the 27 is followed by a 9, that's why we bump it up to a 28. Okay. So put y equals into your calculator with whatever that number is, and then just look to see where it crosses. Okay, last example. Oh no, the mad scientist, Dr. Lupenbaum, has lost most of his data from his most recent experiment. He's researching a formula that grows hair for bald dogs. He has only 2 data points. Okay, but it says he knows that it's a linear relationship. Use them to predict how effective his formula is at growing hair for those poor old ugly dogs. His units of measurement are in days past and average centimeters of hair growth. Now, when I made this copy, I accidentally put the points on the last page. So if you'll just flip over, we're going to steal these points from right here. So it's 3,2.28. And 8,5.98. Okay. Now notice that even if I only have 2 points, okay, I can still do this process. I'm going to take those 2 points. I'm going to organize them into a table. So I'm going to do 3,2.28 and then 8,5.98. Okay, then from there, we're going to follow that exact same procedure. So I'm going to go into my Desmos. I'm going to input my equation. I'm going to do regression on it to find out what that is. And then I'm going to look at the R value to see overall if it looks like this is a pretty accurate measurement or if it's not very accurate. Okay. So let's do it. So I'm over here back at my Desmos. Okay, I'm just going to go to Desmos to eliminate all that stuff. Oops, desmos.com. Graphing calculator. And we're ready to hit the plus and then insert our table. Notice that this table is going to be really easy to do because it's only got 2 points. So I have 3,2.28. You can see it over here on the graph. There's my little point. And then 5.98 right here. Then I'm going to come down to my new line. y1 squiggle mx1 plus b. And then you're going to notice that all of this stuff pops up that I need. Now with only 2 points, look at my R, it's a 1 again, because these points are perfectly fit by this line. It's passing through both of them. So let's go ahead and record what we got for our answer. So it's y equals, my M I can see right here is a 0.74. And my B is a 0.06. Okay, then it says, what's my accuracy? Okay, I can see that right here. My R is a 1. Okay, and 1 indicates a perfect positive correlation. Okay, then it says the dogs have an average of blank centimeters of hair at the beginning, and it grows at blank centimeters per second. So my dogs are starting, remember they're bald, sadly, okay, with 0.06 centimeters of hair. But then this amount, the slope, is telling me how much it grows. So the initial value is how much you're starting with. And then the slope or the rate is going to tell you how fast it's growing. So it says they're starting with 0.06 centimeters of hair, and then it's growing at a rate of 0.74. Okay, then it says, how much hair will the dogs have after 13 days? Okay, so remember that days is going to be your X value. The amount of hair that they have is going to be your Y value. And remember that this is the easier direction to go, because all you really need to do is put this equation in and then put 13 into the table. So I'm just going to add 13 to my table here and put a question mark right there. So let's come over here to Desmos and type this in, please. Okay, let me erase these markings. We're going into a third bar. Y equals, my M was a 0.74x plus 0.06. Okay, notice my line perfectly fits through both points. And then I'm going to open up my table using the gear. We've used this before. And then I'm going to click on my chart right here. Now notice this gives me a whole bunch of numbers, but I don't really want all these numbers. I only care about 13. So I'm going to take that 2 and swap it for a 13. 13's partner is 9.68. So what that means is that if we waited 13 days, the dogs would have on average about 9.68 centimeters of hair. So woo, Dr. Lupenbaum cured dog baldness. Who knew? Okay, so at this point, you are going to receive your practice. Okay, so Mr. McCormack and Mr. Khan should be passing that out shortly. If you need help, please ask each other. Please ask your teacher. And I will see you guys next week. I'm so sorry that I couldn't be here. If you finish your practice, go ahead and turn it in. If you are not able to finish in class, then you can turn it in next week. Okay, have a wonderful day. Thank you so much.